3.6 Compound Inequalities. The learning target is to solve and graph inequalities involving the word and or. Our math terms: compound inequality. Two inequalities that are joined by and or. Interval notation. A notation for describing an interval on a number line. Writing and graphing compound inequalities. What compound inequality represents the phrase? And graph the solutions. Number 1. All real numbers that are greater than -2 and less than 6. By reading this, you should see that we're looking for the numbers between -2 and 6. However, how do we begin to write that, and what if when we're reading it, it's not as obvious? So we'll start by writing the first inequality, which is that n is greater than -2 and n is less than 6. So we start with saying that. Now if n is greater than -2, I could switch the order and write it like this also. -2 is less than n. Now this is just the steps to see where it comes from. But if you see here, n is both in the middle, so we can write this as a compound inequality saying that n is going to be greater than -2 and less than 6. And whenever we have the word and, we should be able to write it as one actual inequality. You shouldn't have to write two separate ones. And sometimes it helps if you see the graph first, actually. So let's look at how this would look on the graph. Here's our number line. And we have -2, -1, 0, 1, 2, 3, 4, 5, and 6. And if n is greater than -2, I put that open circle and it's going to go to the right. And if it's less than 6, I'm going to put that open circle and it's going to go to the left. So, since it's and, it has to be both of them. So all of the solutions are these numbers between -2 and 6. And that's how we can write that compound inequality, -2 less than n, which is less than 6. And it also can be thought of as n is between -2 and 6. So let's look at the next one. All real numbers that are less than 0 or greater than or equal to 5. Well, as you read this one, you should be able to see that you're not going to find a number that is less than 0 and also greater than 5. So this one is not going to be able to be written like we did the one above. We're going to write it as two separate ones. And the other hint is that word or. Okay, if you looked back up top, it had the word and. They're going to be combined. This one has the word or. So we're just going to write them as two separate inequalities. We can use any variable we want, so I'm going to just use t this time. T is less than 0 or t is greater than or equal to 5. So when we have or, we're not going to be able to write them together. And again, the graph will help you see that. So here's my number line. I have to fit quite a bit in here so that I can show numbers that are greater than 5. Okay, so for t is less than 0, I put that open circle on 0, and my arrow is going to go to the left. For t is greater than or equal to 5, I put a closed circle on 5, and my arrow goes to the right. So none of these will intersect. None of these solutions will work for both of them. Where above, you have that intersection, that graph meets in the middle, because those solutions work for all of them. Solving a compound inequality involving and. So now we're going to solve these and figure out what numbers m falls between. Again, when it's and, we're going to have that in the middle. We're not going to have two separate ones. Now, when we're going to solve this, it's not that different than solving any other inequality. It's just like solving two separate ones, but we don't have to do it as two separate ones. We can just realize that whatever we're going to do to the m, we have to do to both sides of the inequality. For example, in order to get m by itself, I have to add 4. So I have to add 4 to both sides. So negative 3 plus 4 is a positive 1. We just have m in the middle. And then we have negative 1 plus 4 is a positive 3. And we graph that. 1, 2, 3. And we're going to include 1. And m is greater than 1. And we're not going to include 3. And m is less than 3. And both have to be true, so that intersection is the set of solutions. Number 4 is solving a compound inequality involving or. Now this is two separate inequalities, and you're going to just solve them as two separate inequalities. 3t plus 2 less than negative 7, negative 4t plus 5 less than 1. So we'll start with this first one and subtract 2 on both sides. And we have 3t is less than negative 9. We'll proceed to divide both sides by 3. Since 3 is positive, I do not have to flip the sign. And I have t is less than negative 3. Now the second equation, we're going to subtract 5 from both sides. And we have negative 4t is less than negative 4. Now this time we're dividing both sides by a negative 4. So we do have to flip the sign, and we end up with t is greater than 1. Now we'll graph our solutions. Since this is or, they're not going to have anything in common. On the right-hand side, we have 0, 1, 2, and 3. And on the left-hand side, we can have negative 1, negative 2, negative 3, and negative 4. So t is less than negative 3. I put an open circle, and it's going to go to the left. And t is greater than 1. I put an open circle, and it's going to go to the right, which makes sense because you can't find a number that is greater than 1 while also being less than 3. Writing and solving a compound inequality. So with our word problem, we're first going to read it. To earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86 inclusive. Inclusive means included. Okay, so 84 and 86 are included, so you can have an 84 and 86. So we'll have that equal to sign. You scored 86, 85, and 80 on the first 3 tests of the marking period. What possible scores can you earn on the 4th and final test to earn a B in this course? So as any word problem, we will start by listing what we were given. Okay, the average greater than or equal to 84 and less than or equal to 86 is what we need. Current scores are 86, 85, and 80, and X is going to represent our 4th score. Again, I just want to point out the word inclusive means including. Okay, that's why I said greater than or equal to and less than or equal to. So now we need to start setting up the inequality. And to start, we know that we want our average to be greater than or equal to 84 and less than or equal to 86. Now we have to remember what an average is. An average would be, I would add my 4 scores and divide by 4, because that's how I'd find an average. We don't know that 4th score, but we can plug in our X because that's what that represents. And that's going to be our average. So to begin simplifying, I would add 86, 85, and 80 to make that a little simpler, and that equals 251. So we have 84 is less than or equal to 251 plus X divided by 4 less than or equal to 86. Next, we have to remember how to get rid of fractions. We multiply everything by 4. So I'm going to multiply this fraction by 4, this by 4, and this by 4. These two 4s will cancel. On the left side, we multiply, and we get 336 is less than or equal to 251 plus X, which is less than or equal to 344. We'll subtract 251 from both sides. And we are left with 85 is less than or equal to X, which is less than or equal to 93. Now this is a word problem, so we do need to come up with word answers. So test scores must be between 85 and 93 inclusive. Again, that tells us that it can be 85 or 93. Interval notation is used to describe an interval on a number line. Parentheses, you use them when a less than or greater than symbol indicates that the endpoints are not included. So when we don't have that equal to part, we use parentheses. Brackets, we use when the less than or equal to or greater than or equal to symbol indicates that the endpoints are included. So you can think of parentheses as being that open circle and brackets as being that closed circle. In infinity, we use infinity when the interval continues in a positive direction, and we use negative infinity when the interval continues in a negative direction. So we're going to start by graphing these inequalities. So first I have x is greater than or equal to 2. So we'll graph that on our number line. And I have 2, 3, 4, 5, and 6. This is going to be a closed circle, and it goes to the direction of the right. Now I want to point out that it's a closed circle. This includes all the numbers from 2 and greater all the way to infinity. So that's where the term infinity comes from. And this goes in the positive direction, so it goes to positive infinity. Now when we talk about infinity, that's never going to have a bracket next to it, because the bracket justifies the fact that it is included. The infinity can't be included because it's not just a number. It goes on forever. It represents various numbers. So for our interval notation, if you look at our graph, we started at 2 and we included 2. So since 2 is included, I put a bracket with a 2. Then I put a comma, and then I'm going to put infinity with parentheses. Again, infinity will always have parentheses next to it, and this notation is saying that I'm starting at 2 and I'm including 2, and it goes to infinity in the positive direction. So let's try another one. X is less than 2. So I'll draw my number line. 2, 1, 0, -1. An open circle going to the left. This time the arrow is pointing in the direction of negative infinity. So I'm going to start with that. We always start with what's on the left. Since it's going to negative infinity, I'm going to put parentheses, negative infinity. The number on the right, which is the greatest number, is going to be 2, and we're not including 2, so I put a parenthesis. So your greatest number is always going to be on the right, and your smallest number is always going to be on the left. Now we have a compound inequality, so let's start by graphing it. So we start with 1, and it goes to 5. 1 has an open circle. We're going to go over to 5, and 5 has a closed circle. So the smallest number, we don't have infinity anymore because it actually starts at 1, and it's an open circle, so I'm going to put 1 with the parenthesis, and it ends at 5. It doesn't go to infinity, so I'm going to put 5 with a bracket because we're including 5. Now when we go to the OR statement, we're going to graph it, and we have x is less than -3 or x is greater than 4. So we'll have 0, 1, 2, 3, 4, and 5, -1, -2, -3, -4. So x is less than -3, we have an open circle going to the left, and x is greater than 4, we have an open circle going to the right. Now you can't write these as one set of interval notations because they don't relate to each other. So we're going to have two separate ones. So let's look at the graph on the left first. That one's going to go all the way to negative infinity. That's going to be its smallest number. So we're going to have negative infinity, and its largest number is going to be 3, and we're not including 3, so we're going to have parentheses. And again, infinity always has parentheses. Now I'm just going to write the word OR because we have another one, and this was an OR. It's always OR when they're not connected. Our smallest number is 4, and it's not going to be in brackets. It's going to be in parentheses because we're not including 4. And our largest number is going to be positive infinity because the arrow goes on forever, so that one will go to positive infinity. Now it is your turn to try numbers 1 through 6. Use the examples that I gave you to help you work your way through these problems. Do your best. We will go over it tomorrow. Have a great night.